Right. Everyone see what is the condition for subject to is. So everyone observe uh, total number of onto functions. Total number of onto functions. Total number of onto functions. So here, so n of a is the number of elements in the A set. This is the A set. Elements are represented by X letter. The n of a means number of elements in the A set. So this is the B set. B set elements are represented by Y. N of B means number of elements in B set. Okay, na? So number of onto functions is first one is n of b to the power of n of a, n of b to the power of n of a minus n of b to the c1 n of b minus 1 minus 1 to the power of n of a less n of b c2 and n of b minus 2 n of b whole power of n of a. So up to 0 we should be right. This must be continue up to 0 when mean n of b value c is less than n of a value. At that time only this condition should be applied. Okay, na? This formula should be applied. That is the binomial theorem formula. So when n of b, number of elements in n of b is less than number of elements in n of a, then only you can be applied. So greater than, what is the formula, sir? N of b is greater than n of a. So no elements. So no onto element. N of b is greater than n of a. Sir, equal, sir. What happens, sir? So that is equal to n of b factorial or n of a factorial if n of a is equal to n of b. N of A, N of B, number of elements in A set, B set are equal, then we can apply this condition. Okay, na? So these are the total number of onto function. According that one, N of B elements is less than N of A, then we can apply this one. Up to 0. So we are going on decreasing up to 0 is coming. Up to that part you should be right now. So here, the number of elements is greater than number of elements of A. Now no onto function. Always equal or less than. So equals are, then factorial should be right down. Factorial should be right down. That is the condition. So into function. What is the into function? Into function is not a function. It is a only name. So it is not a function. It is a only name only. What is the into function is? So what is the into function mean? So not a onto. Not a onto, sir. It is a 1-1. Yes, it is a 1-1. Or some other also. No objection. But not onto. Not onto name is into. Into is not a function, it is the only name, no condition, nothing is there. Okay, na? So nothing is there. Into is the only name if it is not a onto function. It is not a function. Many one is not a function, it is the name only. If it is not a 1-1, the name is many one. Sir, many one means it may be onto, it may be some other function, no objection. But it is not a one. It is not a 1-1. The name is the many one. Many one is not a function, it is the only name. So in the same way, into is not a function, it is the only name. If it is not a onto, then we say that it is a into function. Sir, into function I will can't write, sir. It is a 1-1 function I will write. It is also correct. But it is not a onto. It is not a onto. Representation is the into only. Okay, na? Write down everyone. Into function. Into a function. into function is not a function, it is the only name. Into function. Into function, it is not a function, it is not a function, it is not a function, it is the only name. It is the only, it is the only name, it is the only name if it is not onto, if it is not onto, if it is not onto, not onto. If it is not a onto means I say that it is a into is also correct. No sir, I will say that one also correct. Some other function also correct. But it is not to onto means we say that it is a into function. Just only name sake only. It is a name only. It is not a name of the function. No condition, nothing. Into function. Number of into functions are. Number of into functions. Number of into functions is total number of functions minus onto function. Total number of functions. Total number of function minus onto function. Number of onto functions. Number of onto function. In that one, no onto functions. So other functions we have. Other functions we have. What functions we have, sir? One we have, some other functions we have. But it is, there is no onto function. No onto functions. Okay, na? It is the only namesake, but it is not a function. Now we go through the, so everyone see, I will write one question. Find question number 3. Find total number of onto functions. Total number of onto functions such that find a total number of onto functions such that what is the given is such that n of a is equal to 4 and n of b is equal to 3. N of b is equal to 3. Immediately should be see. Here is, I will write hint of the problem is number of elements in B set is less than number of elements in A set. Immediately first formula, what is the formula is n of b to the power of n of A. So n of b to the power of n of A minus n of b c1, n of b minus 1 whole power of n of A plus n of b c2, n of b minus 2 whole power of n of A. It must become up to 0. Up to 0 should be right down. I will start. Everyone see n of b is the 3 element, n of A is the 4 element. 3c1, 3 minus 1 to the power of 4 plus 3c2, 3 minus 2 to the power of 4 minus 3c3. 3 minus 3 will become as a 0. Will become as a 0. Don't take 0. So 3 power of 4 is the 81. 3c1 is the 3. 2 power of 4 is the 16. 3c2 value is the 3. 1 to the power of 4 is the 1. This value is the 0. Okay, na? Right, 81. My 81 plus 3 is the 84 minus 48. 84 minus 48. Then we can write down the exact value is the 36 is the answer. That's enough. Number of onto functions is the 36. Number of into functions mean, if they will ask the number of into function mean, first write down the total number of function. 2 power of n of A into n of B is the total number of function. I will write that point also. Total number of total number of into functions is equal to 2 to the power of n of a into n of the number of function minus on number of onto function, number of onto functions, number of onto function. So 2 to the power of n of a is the 4, n of b is the 3, minus onto functions is the 36. 2 power of 12 minus 36. 2 power of 12 write down minus 36 we can do. We get the number of onto function into function. This is the problem. Is it clear? Right. Last one, I go through the for problem purpose only. That is the bijective function we can complete mean. Objective also it is going on completed. We can see objective also going on completed. At a time, objective also going on completed. Okay, na? So that is the objective also completed. Immediately I will start the exercise. Right, see the everyone. Last one, 1 1 on 2, 1 1 on 2, 1 1 on 2 function. That is another name is bijective function. Bijective function. So another name is bijective function. So here number of A set elements, number of B set elements are equal, then only we say that it is a 1-1 function. So that is both it will become as a 1-1 and onto. If f is a mapping from A to B is a function, then if it is a bijective function means it is a both 1-1 and onto. If it is a both 1-1 and onto, that function is called as a bijective function. Every bijective function has a inverse. Every bijective function has a inverse. Everyone, that point should be remembered. Okay, na? Bijective function means it is a both 1-1 and onto function. Bijective function means it is a both 1-1 and onto function. So now I will write definition. If f map A to B is called bijective, if it is both 1-1 and onto. It is both 1-1 and onto. It is both 1-1 and onto. Both 1-1 and onto. Okay, na? Both 1-1 and onto. Condition is number of elements in A set is equal to number of elements in B set. Number of elements in A set is equal to number of elements in B set. Everyone observe. So figure is A set elements are 3. So 1, 2, 3. B set elements also 3. B set elements are 3. Next one. So 1-1 means one element have one image. One element have one image. One element have one image. Therefore, every element of A set, different elements have different images. That means one element have one image. One element have one image. Therefore, it is a 1-1 function. Next, every image has a pre-image. Every image has a pre-image. That means codomain element and range both are equal. Therefore, it is a onto function. It is a both 1-1 and onto function. See, 1-1 is 1 have one image, 2 have one image, 3 have one image. onto mean every element of the B set have the pre-images. That means codomain elements are ABC, range also ABC. Codomain and range both are equal. It is called as a onto function. Okay, na? So next one. Example is clear, everyone. Figure is clear. Number of bijective functions. Number of bijective functions. Number of bijective functions formula is number of elements in A set factorial, number of elements in B set factorial, or any one. Because of n of A, n of B both are equal. N of A, n of B both are equal. That's why number of elements in A set factorial or number of elements in B set factorial. Any one you should be take. Any one you should be take. Because of n of A and n of B both are equal. N of A and n of B both are equal. Is it clear, everyone? Right. I go through the exercise 1.2. Only 30 members they are joining. Tomorrow onwards, why I am sending the recording? What is the necessary? We are not joining the live means. What about the remaining? Tomorrow onwards, I can't send the recording. Everyone, I tell her, everyone must be joined in live classes. We are playing games. Why you are not joining? We are enjoying. Tomorrow onwards, we didn't send any recording. If we are joining means we are getting definitely. Otherwise, we are not getting. So college is opening means what we are going to understanding. They are giving the permissions, everything. So we are not understanding means what we are going to do, what we are going to write. Corona is not coming for the compulsory. They will conduct the examination. At that time, you have to be open mouth. Right, everyone see tomorrow onwards nobody will be joining means I can't send videos. Immediately it can be remembered. Right, everyone send exercise 1.2. First problem. Exercise 1.2. That useless fellow Sivakumar, still today also he didn't send the assignment. What we are sending the DDP office, when they are going to give the link means we are going to upload, we can the zero we can put the failure also. Responsibility not we are taking means. Right, see the exercise 1.2. So tomorrow onwards, nobody will join means I didn't send the recording also. So those we are joining, they will get definitely. Right, see everyone. First problem, exercise, first problem. Show that the function f is a mapping from R star to R star, R star to R star, R star to R star, defined by f of x is equal to 1 by x. Defined by f of x is equal to 1 by x is 1, 1 and onto. 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 First you have to show that it is a 1, 1 and onto function. That is the problem. R star is the set of all non-zero elements. R star. So is a set of all real numbers, no zero. So R star is the set of all real number, non-zero real number, no zero. Zero is subtraction. Next, is the result true if the domain R place replace? Second one, is the result true? Is the result true? Is the result true? What is the second part of the problem is given? If the domain is first set. If the domain R star is replaced by n, is replaced by n. N is natural number, is replaced by n, natural numbers. With codomain is the same. With codomain is the same. With codomain being same as R star. As R star. This is the given problem. Two problems is there. We have to show that the first problem is both 1, 1 and on 2. Okay, na? Both 1, 1 and on 2. This is the PU syllabus. So first write down R star means set write down. So real numbers without zero, non-zero real number means no zero. First point is completed. F of x is defined by 1 by x. All so 1 by x. First 1 function. 1 function. See the first we have to show that 1 function. Immediately write down the condition for all x1 comma x2 belonging to the domain of R star. D of R star means domain of R star such that f of x1 is equal to f of x2. That implies we have to show that x1 is equal to x2. So that is the given. X1 comma x2 belongs to domain of R star such that f of x1 is equal to f of x2. What we have to show that x1 is equal to x2, right? I will take f of x1 is equal to f of x2. X place replace x1, 1 by x1. X place replace x2, 1 by x2. By the cross multiplication, x2 is equal to x1. Both are equal, we get. Both are equal, get. X1 is equal to x2, we get. Therefore, f is 1, 1. Therefore, f is 1, 1 function. Finish. 1, 1 is completed. Okay, na? Now I go through the onto function. Everyone see onto function. So onto, everyone observe the onto function. Very simply, I will take f of x1 is equal to f of x2. Definition is take f of x1 is equal to f of x2. Show that implies me from this one. You have to show this one. X1 is equal to x2. Okay, na? So I will take second one onto function. Right. Everyone see onto function is onto function. Everyone observe onto function. Right. See the onto function. So what is the onto function is? First let y is equal to f of x. Y place f of x value right now. Y is equal to f of x is 1 by x. Now x value right now. What is the x value is 1 by y. Y is the elements of codomain. Y value substitute, we get the x values or not x values. What is the x value? See the what is the x value? See the what is the x value? See the R star other than 0. Y value also R star other than 0. I will substitute Y is equal to other than 1, then X also 1 by 1 is a 1. It is a real number, X is a real number. Y is a real number, X also a real number. So Y is equal to 2. X is equal to 1 by 2. 1 by 2 is a rational number. It is also a real number. All values have negative also we can see. Y is equal to minus 3. X is equal to minus 1 by 3. Minus 1 by 3 also a real number. Positive values, negative values. Next, fraction. Y is equal to 1 by 5. X is equal to 1 by 1 by 5. That is a 5 is also belonging to the real number. 5 also belongs real. All values have the, so from y we are getting the all the x values. So therefore f is a onto function. If we are not get means it is not a onto function. Immediately somebody will get the doubt is, sir, why I will take root 2, sir? 1 by root 2 also irrational number. Irrational number is also real number. Irrational number also real number. Okay, na? Irrational number also all numbers is except 0. Don't take 0. So we are not taking the 0. We are getting the from y values. We are getting the x real values. Therefore, it is a onto function. How can you represent, sir? After writing this one, you should represent. So this is the figure. A set is the all the real number. The R star domain is the R star. So 0, minus 1, minus 2, and 1, 2 we should be write down. Here also write down. So without 0, sorry, without 0, 1, 2 should be write down. Here also 1, 2. Here also minus 1, minus 2. Every element, 1 have the image of 1, 2 have the image of 1 by 2, and 3 have the image of 1 by 2. Every element have the images. Every element have the images. Every element have the images. Therefore, it is a onto function. Codomain is equal to range. Therefore, onto function. Codomain is equal to range. Therefore, it is a onto. I will draw the big figure. Everyone see. This is the R star. Clear? Now means I will draw here only. You can see R star. This is the A set R star. 1 by 1, 2, etc. Minus 1, minus 2, etc. Here is the R star. Here is 1 by 2, 2, etc. Minus 1, minus 1 by 2, etc. 1, we get 1, minus 1, we get minus 1. See, 1, we get 1, and 1, minus 1 is a minus 1. So we get 2, 1 by 2, minus 2, minus 1 by 2. All elements we have. Therefore, codomain is equal to range. Codomain is equal to range. Codomain is equal to range. Therefore, it is a onto function. Therefore, it is a onto function. Is it clear, everyone? So now what they are giving the second problem is, see, the second problem is, second problem, F is a mapping. First R star domain replaced with the n, second bit, and codomain is the same. Natural numbers we have to take. Okay, na? So that it is a 1 1, not a 1 1, we can check. First 1 1 I will check. Take f of x1.